What we're going to do today is we're going to talk about problems like these, problems that have square roots in them, and how we solve equations like that. This is a pretty simple one, a pretty simple equation with the square root in it. We're going to see some that are a little more complicated, but the steps that we're going to take to solve those equations are the same steps. We're just adding a little bit extra with the square root in it. All right, so when we're solving equations with square roots, what we did in the opener here is first we got that square root by itself. So in that last one we had a square root, but we also had a number outside of the square root. So the first thing we're going to do is we're going to use the golden rule to get the square root by itself. Now, as a reminder that we need to get that square root by itself, we're going to do one more thing when we're setting up the problem. So we're going to circle the variable, we're going to draw the line of equality, and then we're also going to put a box around the square root. And we won't be able to do anything with the square root until that square root is by itself. Okay, that's going to be something that's really important. Once we have the square root by itself, we're going to have to get rid of it. So how do we get rid of a square root? What's the opposite of a square root? A square. So we're going to use a square to get rid of the square root. So once we have the square root by itself, we're going to square both sides of the equation. And the reason we do that is because we want to get rid of the square root. So we square both sides of the equation to get rid of the square root. Once we get rid of the square root, we might have some other stuff involved in the equation, so we're just going to solve that equation like we normally do. So once we get rid of the square root, we're just going to solve as usual. Use inverse operations to get rid of anything else that is with the variable. So let's look at a few examples here. We're going to do 6 of them, I think. First example, we have the square root of c plus 2 equals 5. Now, I want to make sure that we understand something here, because this is really important. This equation is not the same thing as this equation. Why not? Yeah, in this one the square root goes over the 2. In this one the square root does not go over the 2. It's important that we draw the square root so that it goes over exactly what it's supposed to. This 2 is on the inside, this 2 is on the outside. It would also be wrong to do something like this. Okay, a square root is actually not allowed to go over an equal sign. You should never have a square root going over the top of an equal sign. So these two things would be bad. We don't want to do those. We want to make sure that the square root covers exactly what it's supposed to. So in this case, the 2 is supposed to be inside of the square root. All right, so there's 3 things we're going to do to get started with this equation. The first 2 are the same things we've been doing. Circle the variable, draw the line of equality. But then what's the third one, the new one for this? We're going to put a box around the square root. And that box around the square root, notice that it's going around the square root and then also everything that's inside of the square root. That's just a reminder that I need to get the square root by itself before I can get rid of the square root. Now, is there anything on the left side of the equation besides the box that's outside of the box? No. So what that means is the square root is already by itself. Yes. So we don't need to get the square root by itself here because there's nothing else over there with the square root. There's stuff inside of the square root, but that's all part of the square root. So the next thing we need to do is get rid of the square root. How are we going to do that? We're going to square it. So to get rid of a square root, we square it, which is a little 2 in the top right corner. Don't square something by putting the 2 over here. This is not a square. It doesn't really mean anything if the 2 is top left. So a square always goes up and to the right. So we square the left side to get rid of the square root, but if we square the left side, we have to square the right side. What's going to happen with the square on the left side? It cancels out with the square root. So the square root and the square are gone, which leaves what? The c plus 2. So when the square root cancels out, all we're left with is what was inside of the square root. And then on the right side, 5 squared is 25. Now what? Subtract 2. So this is the solve as usual part. We're just solving like we normally do. 2's cancel, leaving c, and 25 minus 2 is 23. Next problem. This one's really similar. We're going to start by circling the variable, draw the line of equality, and then what else do I need to do to get started? Box the square root, and then also anything that's inside of the square root. All right, now, again, the square root is already by itself here, so we don't need to get that box by itself. So the next thing we're going to do then is square it, right? So we're going to get rid of the square root by squaring it. So we square the left side, which means we also have to square the right side. On the left side, the square and the square root cancel each other out, which leaves what? E plus 14. And on the right side, 2 squared is 4. Still have to get the e by itself, though, so what are we going to do next? Subtract 14 from both sides. Alright, so on the left, those 14s cancel, leaving e all by itself. On the right side, 4 minus 14 is negative 10. So we take 14 minus 4, which is 10, and then the answer is negative because the bigger number is negative. Alright, next example. Notice that the 1 is inside the square root, but the minus 3 is outside the square root. Make sure that you draw your square root so it looks exactly like that. So after we circle the variable and draw our line of equality, there's one more thing I need to do. What is it? Box the square root. When I box the square root, that's a reminder, I need to get that square root by itself. Should that minus 3 go in the box or not? No. It's not in the square root, so it doesn't go in the box. So I'm going to put a box around the square root, but nothing that's outside of the square root. So notice that the minus 3, since it was outside the square root, is outside the box. Now, before I can get rid of the square root this time, I'm going to have to get the square root by itself. So that means I have to get rid of what? I need to get rid of that minus 3. I cannot get rid of the square root by squaring it yet because it's not by itself. So I'm going to get rid of the minus 3 by adding 3. Do that on both sides. And the minus 3 and the plus 3 on the left side cancel each other out, which leaves what? The square root of d plus 1. And on the right side, 6 plus 3 is 9. Okay, now the square root's by itself. So what do I do next? Now I can get rid of the square root by squaring it. So once I get the square root by itself, then I can square it to get rid of it. So I square the left side, square the right side. On the left side, the square and the square root cancel, which leaves what? D plus 1. And on the right side, 9 squared is 9 times 9? 81. And then I still need to get the d by itself. So I have to get rid of the plus 1 by subtracting 1. 1's cancel, leaving d equals 80. Alright, next one. While you're writing this one down, I want you to think about something. Is the 2 on the bottom inside the square root or outside the square root? Outside. Okay, good. So when you make your box around your square root, keep that in mind. So we'll circle the f, draw our line of equality, and then our box around the square root is just going to go around the top of the fraction because that's all that's in the square root. That box, again, is a reminder that I need to get that by itself before I can get rid of the square root. So that box, everything that's in that box is going to stay the same until that's the only thing left on that side of the equation. And then I can start getting rid of the square root and the other stuff. So what do I need to get rid of first? The 2. How do I get rid of that 2? Multiply by 2. Multiply by 2 on both sides. 2's on the left side cancel, which leaves what? Good. Square root of f minus 3. And then on the right side, 3 times 2 is 6. All right. So the 2 is the only thing outside the square root. That's all we had to get rid of to get the square root by itself. So now we can get rid of the square root by doing what? Square it. So we're going to square the square root, and then we're also going to square the right side, because whatever we do on one side we have to do on the other. And when the square and the square root cancel, what does that leave? F minus 3. So it's just what was in the square root. And on the right side, 6 squared is 36. Then what? Add 3 on both sides. 3's on the left cancel, leaving what? F. And on the right side, 36 plus 3? 39. Next problem. While you're writing this one down, I want you to think about this. Is the 3 inside of the square root or outside the square root? Outside. So it's going to be outside of your box also. So make sure that the 3 doesn't go inside your box even though it's right next to the square root. We'll circle our variable. Draw the line of equality. Box the square root, which is going to be the square root and the g minus 7, but the 3 is outside of that, which means that to get the square root by itself, I'm going to have to divide by 3. I need to get rid of that 3. So I'm going to divide by 3 on both sides. 3's on the left cancel, which leaves what? Good. Square root of g minus 7. Make sure you don't forget the square root. A lot of people, when they cancel the 3's, forget about the square root coming down here, and that's not good. We need to make sure we have the square root on there also. 9 divided by 3 is 3. All right, then the square root's by itself, so we can get rid of that now by doing what? How do we get rid of the square root? We square it. Remember, squares go top right. So we square both sides. On the left side, the squares square and the square root cancel, leaving what? G minus 7. And on the right side, 3 squared is 9. And then add 7 to both sides. 7's cancel on the left, leaving G equals 16. Alright, so this problem right here, there's actually 4 things we have to get rid of to get the h by itself. We're going to have to get rid of the 4, the 12, the 5, and the square root. Be very careful when you draw your square root that the minus 5 is not inside the square root. And then make sure you're aware of your order of operations and you get rid of things in the correct order. Alright, so to get started, we'll circle our h because we want to get the h by itself, draw our line of equality, and then we also need to get the square root by itself before we can do anything else, so I'm going to put a box around that. So just looking at what's outside of the box. Outside the box we have the 4 and the minus 5. Which one of those should we get rid of first? The minus 5. Remember, these are the same steps that we're taking to solve regular equations. The only difference is this has a square root in it. So we're going to use order of operations backwards to decide what to get rid of first. So we need to get rid of subtraction before we get rid of multiplication. So we do need to get rid of that minus 5 first. Another way to think about it, if the equation looked like this, if it was 4x minus 5 equals 11, what would we do first to get the x by itself? We would get rid of the minus 5, right? So it's the same thing here. We're getting rid of a times 4 and a minus 5. We're getting rid of a times 4 and a minus 5. We need to do them in the same order. All right, so we're going to get rid of the minus 5 by doing what? Adding 5. So we add 5 on both sides. On the left side, when those 5's cancel, we still have that 4 outside the square root. So we have 4 square root of h minus 12 equals 16. I still don't have the square root by itself. I still need to get rid of that 4 by doing what? Divide by 4. So we're going to divide by 4 on both sides. And on the left side, those 4's are going to cancel, leaving what? Not just Square root of h minus 12, good, equals 16 divided by 4 is 4. Alright, now what? Now the square root's by itself, so we can get rid of the square root. So we're going to do that by squaring. So we're going to square the square root, and we're going to square the right side also. So the square and the square root are going to cancel, leaving what? And on the right side, 4 squared is 16. Then what? Add 12 to both sides to get rid of the minus 12. And so 12's cancel, leaving h equals 28.